This is Euclid Book 3, proposition number 32, and we're going to start with a circle. This is kind of complicated, so we're going to start with a circle. It starts at point A, comes down here to point B, comes all the way back up to C, and goes all the way up to D. Alright? Now, we also have a tangent to the circle. It starts at point E, comes all the way over here to point F, and it touches this circle at point B. Alright? Now, Euclid then wants you to draw a line from point B to point D right up here. Alrighty. Once you've done that, then Euclid starts with the proof. First of all, he wants you to prove. Now, the first thing we're going to do here is we're going to say that there are two segments of a circle once you draw a line BD. The first segment is everything above line BD, which is right here, and this is going to be a super humongous area that starts at line BD and goes all the way to this circumference right up here. Okay? The other segment of the circle is starting again at line point BD and comes down here to the circumference of the circle. Alright. Euclid then says, I want you to prove that angle Fbd, well, where is Fbd? Well, here's F here, here's BD, here is F here, here is point B here, here is point D here. So this angle right here is equal in size, has the same number of degrees as angle BAD. Well, where's BAD? Well, here's B here, here's A here, here's D here. So this angle right here has the same number of degrees as this angle right here. At least that's what Euclid's trying to prove. Then he goes on to say that angle EBD right here, well, where's EBD? Well, here's E, here's B, here's D. The number of degrees in that angle right there is equal in size to angle DCB. Well, here's D here, here's C here, here's B here. Okay. Now, the first thing Euclid wants you to do is he wants you to draw a line that is at right angles to the tangent line here, EF. Well, here's EF here, EF, right over here. We're going to draw a line which is at right angles to that line. It's going to start at point B, and it's going to go all the way up to point A. All right. And then Euclid wants you to draw a line from point A to point D, and another line from point D to point C. Alright. Euclid then goes on to say that the center of circle ABCD is on line BA. Here's B, here's A, somewhere on this line is the center of circle ABCD. And we can prove this by Euclid Book 3, proposition number 19. Now, that makes line BA the diameter of this circle. So, if line BA here is the diameter of the circle, then the area on this side of BA is equal to the area on this side of BA. Okay. Now, we can say by Euclid Book 3, proposition number 31, that angle ADB is right. ADB. This angle here is right. We can also therefore say that the sum of, now this is by Euclid Book 1, proposition number 32, okay? By Euclid Book 1, proposition number 32, we can then therefore say that the sum of the angles BAD, which is this angle right here, plus the sum of ABD, which is this one right here, these two angles, their degrees added together would be equal to ADB. Right there. Alright. Now we've already established that angle ABF is 90 degrees. So it's going to be equal to the sum of this angle right here plus this angle right here. That would be BAD and ABD. So the sum of those two angles there is equal to ABF. Now, we're going to subtract angle ABD, from the sum of BAD and ADB, and also from ABF. Well, if you subtract ABD from ABF, what you're going to have is DBF. So that's going to make angle BDF, well, here DBF, sorry, DBF here. That's going to make this angle right here equal to angle BAD here, which is one part of this proof. Now, we have one more thing to prove. We have a quadrilateral in a circle. Now, I know this is kind of hard to see, but there is a four-sided figure inside circle ABCD, which happens to be ABCD. This is one side, this is another side, this is another side, and this is another side. These are four sides of a quadrilateral. And by Euclid Book 3, proposition number 22, opposite angles of a quadrilateral added together will make two right angles. Okay? So, angle DBF, well, where's DBF? DBF here, plus DBE, they're two right angles. Why? Because DBF plus DBE makes EBF. Just happens that way. Okay. So, if DBF plus DBE are two right angles, then we can say that the sum of BAD plus BCD, well, where's BAD? Well, BAD right here, plus BCD, BCD. These are opposite angles of a quadrilateral. And we already said that those two are 180 degrees. So, BAD plus BCD equals DBF plus DBE. Well, here's DBE and DBF, and here is BAD, this one here, plus BCD, which is BCD here. Alright, now we've already established that BAD equals DBF. Well, where's BAD? BAD right here, and DBF, DBF, that one right there. So we've established those two are already equal. So the remaining angles, DBE, DBE, this one right here, and DCB, DCB are also equal to each other. And that's the whole proof. I will tell you more in a future video, so stay tuned.